Hey everyone, welcome back. Hope you're all doing well. In this video, we're going to learn the impacted as planned method for delay analysis. The impacted as planned, or IAP method, is a forensic delay analysis method that forecasts time extensions by inserting delay events into the as planned schedule, assuming no changes to the remaining work. The basic idea of this method is this. If your actions cause delays to the original duration, you should be held responsible for how much the delays changed the schedule. Now, how to apply it? First, we start with the original as-planned schedule, the one created before the project kicked off. This schedule reflects how everything was expected to go if no delays occurred. Next, we take the delay events, usually grouped by category, like owner delays or weather-related issues, and we add them into the as-planned schedule as if they were planned activities from the beginning. This gives us what we call the impacted as-planned schedule. This impacted duration will be longer than the baseline if the inserted delays are on critical paths. Finally, we compare the end dates of the original and the impacted schedules. The difference between those two dates shows us how much the inserted delays pushed the project out, and it also helps us see whether those delays affected the critical path. Now, let's take a closer look at how different types of time extension claims are evaluated using the IAP method. First, to assess the overall delay caused by all delay events, we create IAP1, where all types of delay events are added chronologically to the baseline schedule. The difference in the completion date between this impacted schedule and the baseline gives us the overall project delay. This is represented by the red portion in the illustration. Next, for time extension claims, we construct what we call IAP2, which adds only owner-caused and third-party delays to the original baseline schedule. Since these delays are not the contractor's fault, the schedule impact calculated as the difference between the IAP2 and the baseline is excusable delay, as expressed in equation 2. This forms the basis for requesting a time extension. It is illustrated as the dark yellow portion beyond the blue baseline bar, while the black bar indicates the remaining delay that is non-excusable, which can be calculated using equation 3, non-excusable equals overall delay minus excusable. Now, our next task is to determine how much of the time extension is compensable. To do this, we build a third impacted schedule, IAP3, which includes contractor-caused delays along with third-party delays, added to the baseline. Since owner-caused delays are excluded in this version, the extended portion in gray, or the time difference between IAP3 and the baseline, as shown in equation 4, represents the total non-compensable delay. This includes both non-excusable delays, contractor's fault, and excusable but not compensable delays, such as force majeure. Finally, as shown in equation 5, by subtracting the non-compensable delay, equation 4, from the overall delay, equation 1, we can determine the compensable delay, the green bar in the illustration. When you project this onto the excusable time extension identified earlier, the remaining portion of time extension is not compensable, caused by third-party or concurrent delays. Now, let's walk through this example using the impacted as planned, IAP method. We've got a simple project schedule and 3 delay events to consider. Our goal here is to figure out how much of the total delay is excusable, how much is non-compensable, and how much is compensable. So here's what happened. The owner caused a delay by being late in approving the design. That pushed back the start of Activity C by 10 days. At the same time, the contractor ran into a material delivery issue which delayed Activity F by 5 days. On top of that, there was a third-party delay due to utility relocation, which held up the start of Activity G by 2 days. Just to be clear, we're not changing any logic or relationships between activities in the schedule. All right, we start with the baseline schedule, the original plan. According to that, the project was supposed to finish in 60 days. However, as given, there were 3 delay events: the owner's late design approval, the contractor's late material delivery, and the third party's utility relocation delay. To find the impact of all these delays to the project, we build the first impacted schedule by inserting to the baseline all the delay events in the order they happened. This version of the schedule now shows the project finishing in 65 days. So we've got an overall delay of 5 days compared to the baseline. Now, if we take a closer look at this impacted schedule, we can see that the contractor's delay is the one driving the critical path. The owner's delay and the third-party delay aren't on the critical path here. But that doesn't automatically mean the contractor is on the hook for the full 5-day delay, since some of that time might overlap with the other delays and be considered excusable. Next, we want to figure out how much of the delay is excusable, that is, not the contractor's fault. To do that, we create another impacted schedule that includes only the owner's 10-day delay and the 2-day utility delay. When we recalculate the schedule with just those two, the project now finishes in 62 days. That gives us 2 days of excusable delay that the contractor could ask for as a time extension. Now we move on to the compensable part. For this, we create a third impacted schedule that includes the contractor's 5-day delay and the 2-day third-party utility delay. In this version, the contractor's delay pushes back several activities, including Activity G. Because of that, the utility delay no longer has any real impact. It has been absorbed into the contractor's delay. Looking at the final activity, we see that the schedule still finishes in 65 days. Compared to the baseline of 60 days, this results in a 5-day non-compensable delay, as the impact was not due to the owner's fault. And finally, to find the compensable delay, we subtract the non-compensable time from the total delay, 5 minus 5, which leaves us with 0 compensable delay. This makes sense, as the project would have been delayed by 5 days, even without any fault on the part of the owner. Therefore, any claim for cost compensation is likely to be denied. It means the entire 2-day time extension is non-compensable. To sum up, the contractor is entitled to a 2-day excusable time extension, but isn't entitled to any compensation for delay-related costs. Alright, that wraps up this video on the impacted as planned method. Goodbye, and we'll see you in the next one.